I was watching Soding's video about STB libraries, single header libraries for C programming language. And there are plenty of comments that are skeptical, oh, this only works for small libraries up to a couple thousand lines of code, or oh, C programmers only do this because C doesn't have NPM, which is like, what? But anyway, today I'm gonna show you that this idea of just drag and dropping stuff to your code base scales to pretty much arbitrary complexity, which brings us to the topic of today's video. Oops, Ginger Bill and Łukasz Cameo, SQLite, the best and the most important open source library in the world right now. If you somehow live under the rock, then SQLite is a library that implements an SQL database engine, and it is literally the most used database in the world by a huge margin. Anyway, just let me show you how easy it is to use. You go to download page, you copy the link to its amalgamated sources. So it is just C source of SQLite all dumped into a single file, right? Let's just wget it. There it is. Let's zip this little fella. So, and let's move everything we have here into this. And so, yeah, let's update it. The archive comes with these 4 files. Just to get it out of the way, SQLite 3.ext is a file that lets you implement plugins for SQLite itself. It's like 700 lines of code. We're not going to be using it. .h is the main header. It's like about 14,000 lines of code. There is also shell.c that implements the command line program. So it's CLI for the SQLite. It's about 40,000 lines of code, but we are not going to use it. And this is the database itself. So this is the library itself. And if you look at it, it's almost 300,000 lines of code. And actually, I've noticed that you can see how Emacs is able to very easily cope with it, which I was quite surprised. You can just, start typing code in an arbitrary position. And yeah, I'm pleasantly surprised with Emacs. I thought it's gonna just die when I open this file, but no, apparently Emacs is fast enough. But anyway, here's how you use SQLite. So let's go to documentation, and there was a 5-minute intro. Yeah, there you go. Let's just copy it over and maybe create main.c, paste it, and remove this lines of code here. Yeah. So here we have a minimalistic example of how to use SQLite. And look at this. This is like what, 40 lines of code, and it's that simple. All you do is you open the connection to database, you execute a query, and you have a callback on query execution. That's pretty much it. That's the core loop of the database. And let's compile our executable, which of course it's gonna blow up because we need to link it. And yeah, there you go. So SQLite 3.c, there you go. So let's call GCC, and it's pretty big library. It will take a couple seconds to compile. And now if I call main, yeah, here we go. So, and now if I do, you can see I need to provide a database name and then some kind of a statement. And we can do something like select star from users, and it tells us that there are no users, which we can, I guess, create table users that has, I don't know, like ID, integer, primary key, and name, word, char. I think that's how you do it. By the way, we have a test, which is our database, and then we can do like select from users, right? Select from users. Yeah, there you go. So it works. It was super easy to get started, and I just compiled SQLite statically together with my executable. Maybe you don't want to do that. It is okay. So how you compile a library? Well, you just compile this you just compile this file, SQLite 3.c as a, yeah, there you have it. I already did it before. So just link it against pthread for threading support. I actually don't know if this is needed, right? And this, yeah, this probably needed as well. And you just provided dash shared flag. So yeah, there you go. So now what we have SQLite as a, but by the way, I'm saying both SQLite and SQLite because I just can never decide how to do it in English. So yes, you have to hear both from me. And now what we do, we can, yeah, you can just do this, and now we can look at main. Now it is linked against SQLite 3.so that lives here, but our dynamic linker can't find it because we need to do a library path. And now if we execute LDD, here we go. So I have linked against locally stored shared library. And I'm doing it, by the way, because I also have SQLite 3 installed system-wide. So if I just do -l SQLite 3, it will gonna think that I want to link against, you know, my system library. So I just don't want to cheat. But anyway, now if I run the executable again, you can see that it works just fine. So pretty much in a blink of a moment, I showed you how compile SQLite both statically and dynamically. And please notice something. Have I used CMake? Have I used Ninja? Have I used something else like that? No, I just downloaded archive, I unpacked it, I included a header, and I used just a regular compiler, one-liner to compile everything I need, and it just works. Just think about it for a moment. SQLite is a very, very, very complex project that does very useful and very difficult things. And it's pretty big, right? It's like 300,000 lines of code. So yeah, and it implements pretty much the same single header library approach. When you just have a file that you include, that's it. It's literally the same idea scaled up to unimaginable sizes. And I want to point out at something else that SQLite does that a lot of other libraries don't do. Let's go back to its website, and when we go to the documentation, I just want to show you its, where is it? Introduction to the API, probably, yeah. So look at its API surface. It's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is like a 10 core things that you need to know to start using SQLite. And if you know even anything about SQL itself, these are self-evident. You instantly know what they mean. But below that, or I guess around that, SQLite has more than 225 APIs, but they don't try to dump everything on you. They just show you, hey, this is what you're gonna use like 90% of the time, and everything else you will use if you really need it. So this is how they just take you as a user and funnel you into a pit of success when you don't have to wade through, I know, like Doxygen or some other crap that we all hate in order to start using the library. But they go even further. This is like a masterclass on library design. If you design an open source library or closed source, it doesn't matter. This is how you really do this. Let's say you want to know how to prepare an SQL text. You go to SQLite 3 prepare, and what do we see? Prepare v2, prepare v3, blah, 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 blah. And they explain to you that the preferred routine to use is SQLite 3 prepare v2. This one is legacy, should be avoided, right? But it is still there. So just think about backwards compatibility. Some people used prepare, it worked for them. Then they they can now update to new versions of SQLite without breaking their existing code, because SQLite maintainers, they decided to not be a pricks about it, and instead of saying like, oh, we don't like this architecture, we need to refactor, we need to bring something else, let's break everything. No, they do what Linux kernel does, they don't break user space. You want a new interface, you just call it v2, and you leave the previous one alone. This saves unbelievable amount of dev time for the user. This is how you treat your users with respect. And believe me, I know what I'm talking about. I lived through like 6 major versions of Webpack, and updating from one to the other is like eternal levels of suffering. So every time I see maintainers do something like this, I am always super thankful. And when it comes to npm argument, please feel free to provide CMake, Ninja files like Nix, Flakes, package.json, all the stuff, but try not to demand from people to use them. I think the default way to install any library should be just, drag and drop, or like download, archive, and unpack it. Everything else should be optional. Even if your language of choice has some sort of, industry standard, like npm install, just having an ability to drag and drop stuff will lead to a better library design. I know, just like trust me on this one. And thanks for watching.